Good day and welcome to the African Teen Geeks Online School. Yes, indeed, my name is Nonkululeko Madondo, and I'll be having you here today for Physical Sciences Grade 11. I hope that everybody is doing well. I remember on Friday, we had an interesting lesson where we were talking about the impact of mining. I'm glad to see that. Our usuals are joining us, and I hope they are following through. And I hope that all of you guys are ready because now we're going to be starting with some chemistry. We're going to be doing chemical change. I heard that you guys have done it before, but I thought maybe we should go back to that and go into detail with it, slowly take it easy so that everybody gets to understand each and every step that is happening. So today we're starting once again. I'm starting with chemical change. I think on the Oxford book, it's on Unit 5, Oxford Success. That is a textbook that I usually use, and I think it's better to follow a specific textbook in order for us to be able to follow through, and so that you guys as well can always have your study material in place when it's needed. Okay, I'm Nonkululeko Ndlovu. You can also get me on LinkedIn as Trio Madondo, and you can communicate with me. Oh, and another thing that I want to mention about our lessons is that there's a chat button. Whatever problem, whatever issues that you guys might have, as I'm teaching along, you guys can just chat quickly, and I'll check your messages and I'll try and thoroughly explain whatever problem that you guys are encountering. I'm going to work mostly through the textbook. I hope that you guys will be able to understand everything as it comes through. And I just want us to outline the first module of chemical change. In this case, we're going to be doing it's stoichiometric. Sorry if I might be saying it funny. Stoichiometric. We're going to be doing revision basically. It's all revision from grade 12 because I want us to get slowly through the chemical changes so that you guys understand each and everything. We're going to talk about the number of moles. We're going to talk about molecular mass, molar mass, molar concentration, and hopefully, if we still have time, we'll already start the percentage composition because I'm trying my best so that at least we do 1 unit a day. In that case, we just focus on that, we deal with that, and you guys, so that you guys can be able to do specific homework that will allow you guys enough time to understand and do the problems. And what I'll do is that tomorrow, before we get through the next lesson, then we can go through your homework and see if you guys are understanding all the stuff that needs to be done. Um, let's just go to, okay, let me get to the textbook that we're using. As I mentioned, that we're going to be working from Module 5, Part 1, Chemical Change. I know that some of you guys understand it, but I also know that there's people that still are a bit lost with regards to certain definitions, maybe, and certain understanding of certain concepts. And that is why I wanted us to start straight from Module 5 and go through this. In this module, we'll discuss quantitative relationships between reactants and products in chemical relationship. And in our case, this is what is known as stoichiometric. So basically, what you have, for example, it's the maths, like they mentioned, it's the maths of chemistry. It's where you say 1 plus 3 is equals to 2 plus 2. And you sort of like balance that out. So that is what we are going to be dealing with here on stoichiometric relationships to determine how much product will be made from a specific amount of reactants. So before we go through that, I just want to see, I see there's an outline there. As you can see here, say chemical change part 1. We can see that the stoichiometric concepts is divided into three parts. In this case, we've got the molar mass and molar concentration, which is what we are going to be starting with today. And then the next part is molar volume and gases. And then the third part is the reacting solutions. And each one also has a subdivision. As you can see there, it's making up of standard solutions. And then with the second one, explosions and airbags. And the other one is balancing equations, limiting reagents, and experimental yields. So these are all the stuff that we are going to be working with in this part of chemical change. So, as I've mentioned already, what is stoichiometric? Stoichiometric is a branch of chemistry that deals with quantities in chemical reactions. So basically, what this means is that you're dealing with mixtures. Basically, how much amount you use for a certain outcome, how much is it out of, for example, if you mix two of them, how much out of the two is a percent for a certain one that you're using. It provides the quantitative relationship between reactants and products. So this one is the base of chemical change, because here we're dealing strictly with quantities, how much is put, how much is there, and all of that. Simply put, stoichiometric is the maths behind chemistry, and that is what we're going to be dealing with. Revision of stoichiometric concepts and terminology. So we're going to start at the top with the mole and the Avogadro constant. Okay, a mole of a particle is a certain number of the particle. Just like the word dozen represents the number of 12, a mole is represented by 6.02 times 10 to the power 23 particles. This number is called Avogadro constant. So, which means basically you can't talk about a mole without talking about the Avogadro constant, because, like they say, the number 12 is the Avogadro constant, and the number the name of mole is like the word dozen. So a mole amounts of substance that contains the number of elements same amount of substance that contain the same number of elementary units as there are in carbon 12 atom, in exactly 12 gram of carbon 12. And the Avogadro constant is the number of atoms or molecules in 1 mole of a substance. The symbol that we use for the Avogadro constant is Na. So this is the first definition that we're going to be talking about. And stoichiometric calculations involving the number of particles and the amount of substance. So, which means that we can use this to find the number of particles. What does that mean? It means that when you look for the number of moles, you can use X, which is, for example, X is usually the number of particles, which, for example, they can say, let's say you are trying to make an experiment, they give you 12 gram of carbon. That gram, that number of substance is the one that we're going to be using as X. So 12 gram of carbon, and you divide that by the Avogadro constant so that we can find the number of moles. Why do we do that? Because number X is given in grams and Na is given in mole, grams per mole. So what we're trying to do here, we're trying to cancel out the gram and get the mole value. We've got a substance in gram. We want to convert it into mole. So this is basically what is happening here. It's almost like going from substituting, you're going from gram to mole. And this is the formula that we use, the number of moles. So a worked example we can find there: in 5 mole of water, determine the number of water molecules, number 1. Number 2, the hydrogen atoms. I like this example specifically because it shows 2 things that are happening in one problem. Basically, in water molecules, they say 5 grams times the Avogadro will give you 3.01 times 10 to the power of 24, right? Water molecule. Here, it's a water molecule. So it's like we're going to say 5 times 6 times 6.02 times 10 to the power of 21 times 1, because it's one molecule that we're dealing with here. But if you check for the second one, they say hydrogen atoms. Hydrogen atoms, in this case, we're breaking it down. It's got 2 hydrogen atoms per molecule of water. So in this case, it's going to be 5 times 6.02 times by 2 again, because now we are dealing with an element. We're no longer dealing with a compound. So that is what is happening there. But you guys can check through it again. I'm sure we're going to have some more examples, especially with the homework that's going to come. But if you guys have problems and there's somewhere where you are not, okay, I see there's a chat. If there's somewhere where you're getting stuck, just let me know. I am here to help all of you. I see there's a chat there. I hope I'm not leaving anyone behind. Okay. Okay, no, it's perfect. Okay, thank you, everyone. Then we start going to the formula mass. The formula mass is actually known as the molecular mass. I know there's people that have a problem with confusing molecular mass and the molar mass. Molecular mass and the molar mass. So molecular mass is a sum of atomic masses of all the atoms in the molecules of a substance. Atomic mass is measured in atomic mass unit U. The sum of the atomic masses, yes, indeed. So to get this right, we always need a periodic table. You cannot work on chemical changes without a periodic table. Why do I say this? Because sometimes, as you can see there, it's relative. I'm just trying to show you guys something. Check there on the example. They say relative formula for mass of CuSO4 5H2O. Sometimes, and it might happen in the exam, that they just give you this, or even in the test that you guys are going to write, they just give you this. So you need the periodic table for this, because this information can be found on the periodic table, the relative molar masses of each component, because Cu, for example, it's 63.55, which I'm just trying to find quickly, a little element that can show what is what. I'm just trying to show you guys, because I want you guys to see where you find the relative mass of an element. Okay, I'll check it through. Okay, you know what? We'll get back to it. For now, let me just continue. We'll check it as we go. The atomic mass, you see that variables. Calculate the formula of mass, mass of copper 2 nitrate. The atomic mass is a number that you'll find as a lot of decimals on the sides, and that part is what we call as atomic mass, and you're going to use it throughout your chemistry because it'll always be required. And sometimes it's good, to know some of your chemical atomic masses, because you might never know when you get to an exam and they ask you about one that is not there. But we hope they're not going to be that mean. But nonetheless, when you work on these problems with chemical change, always have a periodic table. So as you can see there, with the mass, they say calculate the formula mass, which is the molecular mass, not the molar mass, the molecular mass. Basically, they want to know in that molecule, how much is the mass of the copper nitrate. So what you do here, what we know is that it's always the sum of each individual element. So for example, for CuNO3 in the bracket 2, what you do is going to be Cu plus. You do not multiply. I know I said this is the maths of physics, but it doesn't necessarily always work with maths as we know it. In this case, when you calculate the total molecular mass or slash formula mass, you have to add them together. But the ones in brackets are always multiplied. For example, Cu plus 2 times everything that's in the bracket will be No plus the O, which is you use a 16 times the 3. Don't ever forget these ones, these numerals underneath. You must always multiply. They are the only ones that get to introduce multiplication in our calculation. But other than that, you always add them together. Please let's not forget that. So something to remember that they mention here, the number 2 refers to the positive valency of a copper ion. A nitrate ion is NO3 negative. Okay, I hope you guys are following through with what I'm saying here. Okay, then let's move through to relative atomic mass. The relative atomic mass of an element is the ratio of the average mass per atom of an element of a mass of carbon 12 atom. Because it is a ratio, relative atomic mass has no unit. You'll find relative atomic masses listed for all elements in the periodic table, which is what I already mentioned, that you need your periodic table all the time when you're dealing with chemistry. Anywhere, anytime, you must have the periodic table if you want to find certain things in your work. So for example, there we have that one again that they've given us, but you see what they've done as well. Again, they made sure they added them together, and then they bracketed the one that have more than one, like 04, 02, you say 4 times whatever atomic mass that is, plus, you always plus, guys, don't forget to plus. And another thing that you might made a mistake of is this one here. You see this 5 that's here, make sure you do not forget it, and make sure that you remember that that one is time you multiplied with everything that is inside the bracket. So it will be 5 open brackets 2 times hydrogen plus 16, and then Botmas rule, you add everything inside the bracket and then you times it with the outside bracket. I know there's some students that make a mistake with that, or some people tend to sometimes multiply individually inside the bracket, and that is wrong. Guys, it's maths. Let's get it right so that we can get the right answer. You know, the problem with such things, as we with chemistry, is those problems require, for example, the formula, but you get that at 20, it continues, and you've already got over because you made it. And then next thing stuff, we start getting to the more interesting stuff, which is the molar mass. A molar mass is the mass of 1 mole of atom. Molecules or formula units measured in gram per mole. Okay? Atoms are too small to allow meaningful measurements of chemical substances. To work within meaningful amount of substances, scientists group them into units called moles. Okay? Calculating the molar mass of an element. Okay, that's what I want us to learn as well today. One carbon atom has a relative atomic mass of 12.01. This mass is very small and cannot be weighed on a scale. When we work with mass of a substance, we therefore use mole of a substance instead of one particle at a time. Thus, 1 mole of a particle has a mass equal to molar mass. This is why the unit of molar mass is gram per mole. Okay. We relate mass, molar mass, and moles of a substance with the formula. But I want us to I just want us to go through how to understand how to calculate the molar mass of an element. Okay, molar mass is the mass in grams of a mole of a substance using the atomic mass of an element and multiplying it by the conversion factor grams per mole. You can calculate the molar mass of the element. I don't know if you guys get me, but here's an example right here that talks about what I've just said. So they say molar mass is a mass in grams of 1 mole of a substance using the atomic mass, which is the one you get from the periodic table, and multiplying it by the conversion factor grams per mole. You can calculate the molar mass. So what do they mean simply is that for you, in order for you to get the number of moles, the molar mass, which is this capital letter M, just always remember that now we're not talking about molecular mass, we're talking about molar mass. Make sure you don't make that mistake, because I've had students that confuse the two. This one is the molar mass. Molecular mass is the one that we did earlier on, which is yeah, the molecular mass. We've already dealt with that one. That's where you calculate all the other ones and you get an answer for it. So with here, in order to find the molar mass, you multiply this one, which is the number of moles, by the mass of the sample. Do you guys understand me? To calculate the molar mass, you find the sum of relative atomic masses of the atoms and measure it in grams per mole. So here's an example. Mass, this M identifies that we are calculating for the molar mass. And you're going to add them, all three of them, like I mentioned before. You add the Cu, you add the plus the SO4 plus the in bracket, like we did with the other problem before, and this gives you your grams per mole. And then calculating the mass in grams of 0.2 of bromine. Okay, the molar mass again, the mass in grams. So they can ask you anything. I just want to show you here. We were looking for the molar mass. See how you calculate the molar mass. With the molar mass, you don't need the formula to calculate the molar mass. But when you need something else within the formula, you need the molar mass. So what they'll do to you in the test, they will not give you the molar mass. They will give you the mass of the sample. And when they give you the mass of the sample, you should know that, okay, for me to calculate the number of moles, I'll have to calculate the molar mass. And you can always get the molar mass because it's in the periodic table. The elements are on the periodic table, and you can get your atomic masses and add them together, and you have your molar mass. So usually a problem will say calculate the mass of 2 mole. As you can see there, they say calculate 2 mole, but they don't give you the molar mass because they know that you're going to calculate. You can calculate it by finding it on the periodic table. So here you can see bromine, it's Br2. So they said Br. Let me just get a clear definition of the periodic table. Okay, Br. Yes, you see the bromine, the atomic mass of bromine is 79.9. So what they do, they times it by 2, and then now you have the molecular mass. I mean the molar mass of your bromine, and then N already is given in mole, and then you just substitute them into your formula, and then you can find your answer. So basically, molar mass is something that you will always have to calculate on your own, because I know sometimes there's people that like to use what is given and then they get stuck like, oh my word, molar mass, what do I do now? No, you just relax. You go there on your periodic table, you check all the elements, you add them together, but make sure they are right. Don't forget the two things that I mentioned to you. You add all the elements together. Number two, whatever is on the bottom here, like 4 and 2, you times with whatever element it's standing next to. Like for here, it's just going to be for oxygen. Don't times 4 with SO4, just times the O4 with times the oxygen by 4. Even here, it's only the hydrogen that get times by 4. But again, number 3, don't forget the big number just in front of your compound. Here, it means this 5 is going to be times by everything inside of the H2O. So these ones is going to be 5, open bracket, H times 2 in a bracket, plus O, close bracket. So which means you're going to add these two together and then times by the 5. Make sure, guys, you don't make that mistake, because it will really cost you and you will lose the marks. So that's what that was all about. So how to find the relative atomic mass of an element? An element relative atomic mass is the average mass in an atomic of a sample of all isotopes. This can be found in the periodic table of an element, like I've already mentioned. This can be found in the periodic table located in the element, and find the number underneath the symbol of the element. Don't forget that it's a number underneath the element. And then what you do, okay, let me just remove this ads. After that, after you find that, then you can write them down as you're given. After you find your molecular mass, after you find your atomic masses, you can list them down to show that so that just to make sure to make life easier for you. Find the relative atomic mass of the element, and then after that, multiplying the relative atomic mass of the molar mass constant. This is defined as 0.01 gram per mole or 1 gram per mole. This converts atomic grams per mole, making the molar mass hydrogen 1.007 gram per mole, of carbon 12.01 gram per mole, of oxygen 15.994 per mole, grams per mole, and of chlorine it will be 35.453 gram per mole. Some elements are only found in molecules of 2 atoms or more. This means that you want to find the molar mass of elements that are composed of 2 atoms, such as hydrogen, oxygen, chlorine. Then you'll have to find their relative atomic masses, multiply them by the molar mass constant, and then multiply the result by 2. I hope that you guys are still with me. If you have any problem, please don't mind. Just go to the chat button and chat with me. I will clarify anything that you don't understand. I don't want you guys to lose any information. That's why I'm taking so much time with each and every section. Okay, then we go to molar concentration. A solution forms when a solid dissolves in a solvent concentration of the solution the amount of is the amount of solute that is dissolved in each liter. This is in dm cubed of the solution. So remember that a solvent is a substance that dissolves in a solute, that dissolves a solid to form a solution. So basically, I can give you an example of that. A solvent is a substance that dissolves a solid to form a solution. For example, you take nitrogen and chloride. Yeah, but that one is going to form a solution as well. gets diluted in each other, and then they form a solution, and that solution becomes one thing, like NaCl, like even H2O, no, because yes, H2O as well, because oxygen, hydrogen, they form a solution. So those are some of the things that we um, is meant by a solvent, is a substance that dissolves a solid to form a solution. Molar concentration is the number of moles of solid per volume of solution in liters. Okay, you guys understand that? Molar concentration, the number of moles of the solid per volume of a solution. So basically what they mean here is, for example, there's a liquid that you have, and then take a spoon and you're going to put it inside that liquid, and then they want to know how much do you need to put in there. Is the number of moles of the solid per volume of solution in a liter. I hope you guys understand it better. A commonly used measurement of concentration in chemistry is molar concentration. The symbol C represents concentration. Alternatively, we can place square brackets of around the formula of. Okay, I'm just waiting for this to come back. Oh, the internet is going so bad. But basically, the C also has its own formula. Um, okay, I've moved too fast now. Internet. I've moved too fast. Okay, so you see, let me see if I'm in the right place. No, oh, I moved so fast, so quick. Okay, atomic mass. Okay, so we have the formula mass, relative mass. Okay, yeah, we're right here. Solid. So for example, here they mention it again. The NaCl means concentration of solution of sodium chloride. From the definition, we write the formula as Cn is equals to N over V, where N is the amount of solid, V is the volume of the solution, and C is the concentration of the solution in mole per dm minus 3. Using the N is equals to M over mass over molar mass, we then see that the concentration is equals to the mass over molar mass times the volume of the solution. So we can check it out here. We've got a worked out example which says calculate the volume of the 0.05 mole per dm minus 3 solution of sodium iodide, which is NaL. That means 3G of sodium iodide. So how do we work this out? Okay, don't forget, when you're about to do your calculations, you write the M outside to show that here you are finding the molar mass. So the molar mass, we're going to go to our periodic table and we find Na. Na, I can see it's 22.99, and then for iodide, it's 126.90. So you add those two together. You add them, do not multiply, guys. Always add. You add them together, and then you get your molar mass. And then for that, because remember, I told you they'll always give you the gram. They will never give you the molar mass. That you'll have to find on your own. So what we do, our unknown, okay, they want the volume. In order for us to find the volume, we know that we need N. So now, which means first, we're going to calculate the N, which is going to be equals to M over molar mass. And then you're going to get your answer. Remember the answer that I told you about, that it's important to always get your molar mass right, because otherwise it's going to affect the next problem that you're going to have. So you add them together, you divide them, and then you get your N. And then from your N, you can calculate the V. Okay, write the formula, proper formula first. Sometimes they give you marks for writing the formula, so make sure you always write the formula. C is equals to N over V, and then V will be equals to N over C. Then you get you substitute your values. N is 0.02 and is is 0.05, and this is your volume. But you must remember, they can ask you absolutely anything there. They can ask you for your volume, or they can even ask you, they could have not given you concentration and given you volume, and you would have had to find the concentration of this. So you must make sure that you always get it right. So these are the problems that we have been dealing with today on our stoichiometric. I hope that everybody is slowly getting and grasping the concepts of this all. I just want to see, I just want to make a quick revision. So which means today we've started with the first part, and we're done with the first part, which means that tomorrow we're going to go to part 2 of the revision of stoichiometric concepts, which means tomorrow we'll be doing the what you call we'll be doing the percentages of the stoichiometric percentages of quantities, etc. But I'll be able to explain it to you properly tomorrow. The reason I don't want to go do it now is because I see the time. The time is almost not on our side, and it's a lot. It's a bit of it needs some time for us to go through it. So what I want us to do now is just go back and rehearse what we've learned today. We've learned what is stoichiometric, and what we know is A plus B is equals to C plus D. Basically, that's it summarized. It's a relationship between reactants and products in a chemical reaction. Remember that all the time. It can be asked in the exam. What is stoichiometry? You know, it's relationship between reactants and products in a chemical reaction. 1 plus 3 is equals to 2 plus 2, basically. And remember, in a reaction, things, they balance out. They don't add each other, they balance out. 1 plus 3 will be equals to 2 plus 2. So revision, we spoke about the mole, and I hope that everybody understands what is a mole. A mole is that substance that contains the same amount of elementary unit as the carbon atom in exactly 12 grams of carbon. So that is a mole. And Avogadro constant is what is the value of the mole, basically, because it's 6.022 times 10 to the power of 23. So it's basically the amount of mole is given in Avogadro constant. Okay, so to find the number of particles of one substance, we can use the formula. We can go back to this formula that I mentioned to you, is that N is equals to X, which is the number of particles, divided by the Avogadro constant. But remember, we go into details with this much more when we actually talk about the number of moles, molar masses, and mass of a substance. And then we go to the molecular mass. I hope you guys now understand the difference between molecular mass and molar mass. So this one is the molecular mass, is the sum of atomic masses of all atoms in a molecule of a substance. Atomic mass is measured in atomic mass unit, which is U. So calculate the formula mass of copper. Okay, this will be given in U. You see there, you're going to add them all, but always remember, like I mentioned before, how to time, what to times and what not to times. and everything else gets added. But every now and then, you've got a bracket that needs to be multiplied by a number. You've got an element that requires to be um, multiplied by a certain number. Do not forget that. And then we spoke about relative atomic mass, which is what you find in the periodic table. This is a baseline of everything. Our periodic table is a baseline of everything. On the number, if you see C on your periodic table, you will notice that there's a number on top and a number at the bottom. The number at the bottom that usually has decimals in it, that is your relative atomic mass. And that is what you will need when you're calculating any formula mass that is asked of you. And then that is the relative formula mass. And then we have the molar mass, the mass of one molecule of atoms, molecules, or formula units measured in grams per moles. So you see, with the molecular mass, your unit is a U, but for the molar mass, our unit is grams per mole. So molar mass, mass of one mole of atom, 1 mole of molecules, 1 mole of formula units. Symbol is M, measured in grams per mole. So one carbon atom has a relative mass of 12.01. The mass is very small and cannot be weighed. We spoke about that they are so small that therefore the mole of a substance, instead we work with mole of a substance instead of particle at a time. Imagine how long that would take to even calculate, if that is even possible. Thus, 1 mole of a particle has a mass, atoms or molecules has a mass in grams, and that gives you 1 mole of a particle of atoms has a mass. Our mass is in grams, and the jamming of the computer, excuse me for that. So basically, we also have, yes, in grams equals to the molar mass. That is why the units of molar mass is in grams per mole. Okay, we worked out an example thereof, and then we got to the molar concentration. The molar concentration, um, there we deal with the volume. Basically, that one is mass, this one is volume. That's the difference between these two. So what we're doing here, um, we convert the grams into volume. That is what is being done basically in simple terms. You're converting your gram into volume form. So we say N is equals to M over M, mass over molar mass. And like this problem that we did right here, um, we converted from gram into mole. Remember, from gram to mole, it means we take whatever gram, we divide it by the molar mass. We take whatever gram, we divide it by the molar mass to get mole. That's why I'm saying we're converting from gram to mole. And this is our answer. And from this one, now we're converting from mole to volume. Do you guys understand this? It's simple if you just, practice the terms with little keywords. Like, okay, now I change from gram, I go to mole, from mole, I go to volume. If you try and memorize it like that, it can get really easy. So that is our lesson for today. And I hope that everybody, has learned something or starting to understand the concepts better. We're going to continue some concepts tomorrow, but I want us to go properly so that nobody gets left behind. And for your homework tomorrow, which we are going to do in the beginning of the lesson, I think we can do all the odd numbers. Let's do all the odd numbers of activity 1. And tomorrow, please guys, please do them. Please do these problems. And then tomorrow, before we start with the lesson, we'll just go through the answers of these problems, and then after that we'll continue with the lessons. But I just want to make sure that we're all in one boat. I know this is revision, but sometimes we are kids, we're young, and we forget. And December comes along. By January, we've forgotten everything. So let's try and refresh our minds once again and do what is right. I am Nonkululeko Madondo. I am your teacher, and I hope that you guys are understanding what I'm doing. Don't be afraid to to come back to me, ask questions. Even tomorrow, if there's somewhere where you got stuck, just get back to me and let me know, and I will definitely go back to that work and we can do more of physics of grade 11. Tomorrow we continue with stoichiometric part 2, and just go there, read through it, and we'll come and unravel it here on the program. This is African Teen Geeks. This is